basic computer, we started with a CPU and memory, and based on the memory size we'll be having address bits. So the memory size that we have considered here is 4096, so we'll be having a 12 bits for address, and data, for each word, it occupies a 16 bit. Okay, so we are started with the different common basic registers that we have used, like a program counter, address register, instruction register, temporary register, data register, accumulator, input register, output register. So we are going for a common bus. So for these all registers, if we want to communicate, if they want to communicate with each other, the complexity increases, the number of wires used will be increases. If one register wants to communicate with the other registers, the complexity increases. To overcome that, we are going for a common bus system. So common bus system means, with the help of that common bus system, all the other registers will communicate with each other. So this is a common bus system. Try to concentrate. So this is your common bus system. So here, as we already discussed about each and every register, let me start with a memory. Okay, so we have discussed about a basic memory size of a as 4096 into 16. So 16 is the data where each word is of size 16, and 4096 is the site address. It specifies an address, means you will be using total 12 bits for specifying an address. Okay, so to understand this, first you must know what are the different operations that we can perform in memory. So it is read, and we have a read and we have a write. Okay, so reading means it reads the data. Processor, it gives one particular address and it reads the data from the memory. A write is, it will write into the memory, it will write into the memory in one particular address is right. Okay, so for a memory you will be having two, one is a read and the other one is a write. So read is reading in a particular address whatever the instruction is present by the processor for execution. Writing is after completion of the execution, with the help of this a write pin, it writes into any one particular address which is mentioned by a address bus, and in that address it writes the result. Okay, so this is read and write. Now let me talk about these three pins which are available for AR, address register. So this is your address register. So we'll be having three. So before going for an address register, so even program counter will also have a three, which is load, increment, and a clear. So what is this load? Load indicates it is loading the address. It is loading an address. Increment is, as we already studied about completely about a program counter. Program counter is what? Anyone? What is a program counter? What is a program counter?
which stores the um, address of the next execution.
Yes, yes, ma. Thank you. So it stores the address of next instruction that the processor has to execute. So we'll be starting with a load. So we this stores an address. Next, after that, after loading inside a starting address, it has to be incremented. First is what? It stores the address. So after storing an address, so let us consider an address called 101 is stored inside there. Next is what? Next is it has to be incremented. It has to be incremented. So we have used a INR, which is used for incrementing the address. Next it will be 102. Next it has to be going for 103 in sequence. In sequence. Okay. So whatever in that particular address we have an instruction, this instruction will be executed. Next 103. For that we are using another pin called an increment pin. And we even have a CLR, which is clear. So when we'll be using a clear in a program counter, can anyone? When we'll be using a clear in a program counter? When we'll be using a clear in a program counter? When?
When the clock is disabled mode.
Yes, when the clock is disabled, you will not have any, we cannot do any operations like loading the contents from a bus to a program counter, incrementing, we cannot do anything. So clock should be in enabled. Clock should be in enabled. So here clear indicates whenever, I already explained about a program counter. So program counter, it stores the address of next instruction that the program has to execute. Next, the responsibility of this is it automatically increments. So that means the program counter is executing in sequence. The program counter is executing in sequence. Next is what, when there is a subroutine call. When there is a subroutine call, it cannot go for increment, so it has to clear that. So it has to clear that the next address 105, and it has to load with a new address called 207. So this is a 207 where there is a subroutine call. So what it has to do is it has to uh, clear, then it has to load with this particular subroutine call address. So that's the reason that we have load, increment and clear. Okay, so even for address register also, we'll be having a load, and we'll be having an increment, and we'll be having a clear. So even for a data also, in some cases we'll be in a data register, we need to increment. So we'll be having a load, increment, and whenever we want to clear the data register which is available in this, we can use a clear option. Okay, so this is basic that we have to study. Now even an accumulator also, we have a load, increment, and we need to clear. Now coming to instruction register. Okay, coming to instruction register, we have only load, we don't have increment and clear. Okay, why? In an instruction register we have only a load option, we are not incrementing and we are not clearing. So what is instruction register? Can anyone tell me the format of an instruction format, ma'am? Instruction format. Instruction format.
Mode, opcode, and address book.
Yes, ma. Thank you. So we have a mode which is represented as I, and opcode, and address, address. Okay. So here we are not incrementing it. So what we will be incrementing, whether opcode or address or a mode. So there is no option for instruction register and increment or clearing. So it just loads based on that, whatever the address which is available here will be giving to address register. For opcode, we'll be generating a corresponding decoding operations. It will be sent to the control unit for deciding which opcode it is there in this, whether addition, subtraction, and this mode bit will decide whether it is a direct and indirect. So that is the reason for instruction register will be having only a load. So even you can observe in the output register also. So we have two registers with a size 8 bits. Okay, with a size 8 bits. What are those? Input register and a output register. So input register is whenever you are giving input from your input devices, that it will go directly inside an input register, and with this input register, whatever the operation that you performed in that register, it goes to ALU for execution, and the result will be stored in an output register. From output register it goes to an output devices. Commonly as will be a monitor is commonly used in output device. It will be displayed to the output device. So that is input and output. So for displaying the output, so there is no need of incrementing all those. So it is only used for load. It is only used a loading. So loading is after completing the execution from an input register, it goes for ALU. Then after performing the result, it is storing inside an output register. From output register, it goes to any one of the output device called a monitor for displaying the output. Okay, so when the what is this load will I will be discussing. So till now I explained about the read write in a memory. So memory will have a read and write. Read is processor will read by specifying a particular address, and whatever we have that will be read by a processor. Write is after execution, it will be writing inside a memory. And for each and every register we have three pins called a load, increment and clear, but only for instruction register and a output register we'll be having a load. We cannot do for instruction register incrementing. Why? Because we have a format. Instruction will have a format which is of having a mode, a code and an address. We cannot decide if we are performing an increment to which we want to increment. So that's the reason for instruction register we won't be having any increment or clear. Okay, so let me start with how it executes this actually with the help of a common bus. For that, first of all, you must know the flow. First, which registers should be used, next which register should be used. You must know the flow, then it is easy for you to understand this common bus structure. So let us consider, so we have, see here, let us consider this is your memory. Try to concentrate. So this is your memory and we have an address called 100 101, an address. Okay, so in this address we'll be having an instructions. In this address we'll be having an instructions. Okay, so let us consider, I want to go for the instruction called load A. Okay, so first let us consider there is an instruction called load A and there is an instruction called add B. Okay, so what happens? First, this address, the processor has to go to this particular address. For that, we are using a register called a program counter. Consider the processor is executing some other task. To execute this set of instruction, we have to place the starting address of this in a program counter. So we are the whatever the address which we have in a memory called a 100, this we are storing inside a program counter. Just a minute more. Now program counter. So whatever the address we have, we are placing inside a program counter. Next, this is which stores the next instruction that has to be executed. So immediately this has to be given to address register. Okay, with the help of this address register, it goes to that particular location and whatever the instruction is there, that instruction will be placed in the instruction register. So this 100, whatever we have in a program counter, will be placed in a address register, will be placed in an address register 100. Now if this is placed at 100, so this has to be automatically incremented. So you will be getting in a program counter what value, ma?
101.
What value? Yes, good. So we'll be getting 101. So we'll be getting 101. Now to do that, see here, to do that what happens is, first of all the program counter, this has to be active. Okay, this has to be active. So whenever, you must know the difference between a load and the common bus structure. So this load will be active. So once this is active, whatever the address which is there called 100, so whatever which is there address called 100, this will be loaded inside a program counter. So now a program counter is present with a starting address called 100. Okay, now whatever we have in a program counter 100, it has to be given to the address register. So in order to do that, this bus has to be active. So what happens, we need to give for S2, S1, S0. So this is what it is, like selection pin. So when this will be selected program counter is when you will be having 0 1 0. So when you will be having 0 1 0, that indicates that whatever the contents which are present in a program counter can be placed inside that bus. Okay, so now once it is showing the selection pins as 0 1 0, that indicates whatever the 100 it is loaded, it can place inside a address bus called 100. common bus called 100. So once it is placed from here, from here it has to go to which register, ma? From a program counter, it has to go to which register?
Address register.
It has to go to address register. From address register, it goes from memory, and in that memory, whatever the address which is mentioned, this you will be having an instruction in that instruction we have to store inside an instruction register. This is a process. So for that, the selection line, it is showing as 010. That indicates the contents in the program counter can be placed in a common bus. Yes, placed. Next, with the help of this common bus, it comes here, and here we'll be having a load pin as high. So once this is high, whatever which we have in a common bus called a 100, which is placed by a program counter register, will be placed in an address register 100. Now it is clear. Now next is what? Now address register is ready. Address register is very ready. Means what? Now the processor has to execute an instruction which is present in an address 100. So this instruction has to be fetched, and this fetched instruction must be placed in IR, instruction register. For that, we have a direct connection. See here, we have an address, so it is going to this with the help of an address bus. It is taking an 100 as an address and consider this as a memory. So if you go to that address, it is showing as load A. So what it will be doing, this load A has to be placed in a common bus again. From this common bus, it has to be placed in an instruction register. For that, which selection pin has to be there, ma'am? So for placing whatever in a memory, whatever the instruction which is present in this particular address called 100, which is load A, this load A instruction must be placed in a common bus, so that this address, the instruction which is there in this particular address, can be moved to an instruction register. For that, the selection lines should be what, ma? 7 indicates. 7 indicates. How to represent 7 in a selection lines, ma? We'll be representing with
All
7.
ones, ma'am.
Yes,
All
ma.
ones, ma'am.
Yes. So all ones. So if all ones means whatever the we have in that particular address called an instruction will be placed in a common bus, which is load A. So this load A has to be placed in which register, ma? This load A has to be placed in which register?
Data register.
Is it a data register or an instruction register?
Oh, instruction.
Yes, instruction. So I already clearly mentioned that memory will be of 2 partitions. One side will be having an instructions, and the other side will be having a data. If you are going for that particular location, if you have a data, then you can go in, you can place in the data register. Now we have an instruction in that particular location, so we need to place a that load A, we need to place inside an instruction register. So this load will be active, so that the instruction called load A will be placed in a instruction register. Now next task is what? So after placing inside an instruction register, this is very important task, try to understand. So we have a load A in an instruction. So everyone knows that instruction will be instruction format you must know, then only you can understand clearly. So in an instruction format, we have 3 partitions. Instruction format will have 3. So what are those 3? Just now in one of the students said, we'll be having a mode, we'll be having an opcode, and we'll be having a address. So we'll be having an address. So load A, opcode is load, address is A. So if you go to that A location, you will be getting an data. So load A, and here what does the sign indicates, ma? What does the sign indicates?
Whether it is direct or indirect.
Yes, whether it is direct or indirect. If it is 0, then it indicates it is direct. If it is 1, then it indicates it is indirect. Okay, so 0 indicates direct, 1 indicates indirect. So based on this, now let us consider for sake of understanding. Let me show with an example clearly. We have here 201. Okay, means what? We have a memory. We have a memory with an address called 100. So this 100 we placed in a program counter, and this selection line is selected so that the content in the program counter will be placed in a common bus. From that it is placed in a address register. Next, from this address register, whatever the instruction which is present in that particular address will be placed in a common bus by selecting a selection line as 111. Next, from that instruction has to be loaded in an instruction register. So this is all completed. So let me say load. Let us consider 201. So we have 0 here. Okay, 0 is direct. So if you go for 201, we have a data called 10. Okay, data called 10. So now for that we need to utilize again an address register. See here, you'll be having an address in this address part, and the address which is mentioned in this, after decoding we can able to identify that this is an address called 201. So this 201 again, it has to be placed in a address register. So for that, after decoding, we have instruction formats of 3 partitions. Opcode is used for generating a corresponding signal. Based on that, it performs a load operation. So now, in order to load the data, it has to go to that particular address again. So for that, again we have to use one of the register, which is an address register. So whatever the address which we have, can you tell me the address bits, ma? It is from 0 to 16, or is it from 0 to 11?
0 to 11.
Yes, 0 to 11 is address bits, and remaining 4 until 14 is an opcode. 15th bit is a mode bit. Okay, so whatever we have in 0 to 11 means it will not be represented in this way. It will be represented in a binary representation. So let us consider in this address, in this address 0 to 11, what we have, 0 to 11, we have some address called 011. So in a binary representation, so it goes to that particular address. For that, we need to load this address in an address register. Why? Because only this address register is used for getting the data, whatever we address we mention. Only with this register only we need to communicate. So for whatever that we have in an address in this instruction register, this address part, again this address part has to be stored in an address register. For that, first of all, the selection pins has to be active. Then only whatever the address which is mentioned will be placed in a common bus. So for that, the selection pins should be what, ma? 1, 0. Yes, 2, yes, 1, yes, 0 should be what?
101.
101. Then whatever we have in an address, I'm placing only address. We have 3 partitions in that. I'm using only this part, and this part is 201. So this 201 will be placed in a common bus, and this 201 will be going to, and this load pin will be active, so that this 201 will be placed in a address register. This 201 will be placed in an address register. Again it goes to that particular address, and what will be getting now? Is it an instruction or is it a data?
Data, ma'am.
Data. So again, will you place this data in an instruction register, or will you place in a data register?
Data register.
Yes, that you must know the difference. Okay, so this data, whatever we have, this data must be placed in a common bus. So for that, again the selection lines yes 2, yes 1, yes 0 must be what, ma? What must be what? For placing whatever we have in that address.
011.
See this, we are in a memory. Okay, so memory has to place whatever the address, in that address the data is there, has to be placed in a common bus. With this common bus it goes to data. Okay, so for that, first of all, this data must be, whatever we have in the memory must be placed in a common bus. For that, selection lines must be what?
111.
triple one, so that it places the data. So after that, with the help of this common bus, it goes and it places the data. The load will be active, so that whatever the data called 10 will be placed. Okay, so from this, see here ma, from this it places inside an accumulator. Why? Because load indicates the data has to be placed in accumulator. Whenever there is a concept called a load, that indicates it has to load inside an accumulator. Already we discussed about an accumulator. Accumulator is a special purpose register where one of the operand will be placed in an accumulator. So with the help of a common bus, again will be placed in an accumulator 10. Okay, now let us consider one more instruction called add b. Try to consider. Yeah, I want from you my answer. So now next is what? Add b. Okay, so let us consider, we have in an address called 102. Okay, so now I already said that whenever you are giving the data to program counter date address, whatever we have in an address register, PC will be automatically incremented by 1. Means by 1 means don't consider 101. It depends upon the size of the instruction. If it is 2 bytes, then it starts with 102. So automatically in a PC, by activating a load, it will be storing 102. Next step is what? This 102 must be placed in an address register. For that, first of all, this 102 must be placed in a common bus. So for that, the selection lines should be what, ma?
All ones.
Is it all ones? So we are in program counter in this position. What?
010.
Yes, 010. Okay, so 010 means the address which we have in a program counter will be placed in a common bus 102. Next, one by one you try to unmute and answer ma. With this 102, it goes and load will be active and will be placed here, what? 102. Next, it will go to that particular address, and what will be getting? Instruction or a data? Instruction. So with the help of this address, it goes to that memory location and we'll be getting an instruction. In order to store this instruction, first of all, whatever the instruction which is present in the memory must be placed in a common bus. So for that, what we have to do, the selection lines should be what we need to place the selection lines as in order to place the instruction which is present in a memory in a common bus, we need to place the selection lines as 111. Then the instruction will be placed in a common bus. With this, again it goes to that instruction and load will be active. Once this load is active, this instruction will be placed here. Next step is, I want an answer. Now this is very important. Next step is what? So we have in an instruction add. So let me give an address called 206. In this we have 5. Okay, add 206. Now tell me, next step is what? We should know instruction format will be of 3 partitions. One is mode, opcode and address. We need to utilize this address part. So whatever we have in this address must be placed in which register, ma? Can anyone?
Address register.
So in order to place this in an address register, first of all, whatever we have in this must be placed in a common bus. So for that, the selection lines should be 101, so that the address will be placed here and that address will be passed, and once this load is active, whatever we have in a common bus called an address, that will be placed here, and the address here is 206. Okay, so it goes to 206 with the help of this address. And what will be getting, instruction or data?
Instruction.
Data.
Is it a data or instruction? So we are in 206. So what we have here? Data, right? So should I store it inside an IR or should I store it inside a DR?
DR.
So it has to store inside a DR. So we'll be storing what we have in that address. Again, we'll be placing a selection as 111 so that the data will be available, and again we'll be placing a load as high so that this data we will be having as 5. And we need to do an operation called an addition between the contents which are present in an accumulator called a 10 and the data which is available in the DR 5. So 10 plus 5 both will be done. So this one will be given to an accumulator, and this one will be given to an accumulator, and what opcode we have in the instruction is addition. So addition will be performed and the result will be stored back in an accumulator, and the result will be stored back in an accumulator. Now what is this E? Okay, so whenever you're performing an addition, there may be a carry generated, means there may be a carry generated. In such case we will be using a extra bit or an extended bit, which is a flip flop. As everyone knows, flip flop is what, how many bits it can store? It is a flip flop.
1 bit.
Yes, it stores only one bit. So this, whatever the extra bit that is generated will be stored in this E, okay. So whatever the data register we in that particular address called a 5 and what we have in an accumulator 10, both will be added and the result will be stored back in an accumulator, and you'll be having a result as 15, So this 15, again, if you want to store back in a memory, what happens? What will be the next step, ma'am? So I want the result to be stored in a memory again. So whatever we have in an accumulator value as 15, I want to store it in a address. So again, so this has to be active. So 4 has to be active. So selection lines should be 100 so that the accumulator content will, whatever we have performed after execution of a addition, you will be getting the result. This result must be placed in one address, so it goes to that memory, and there will be an option called write will be active. So once write is active, whatever the address it is mentioned in the address register, it will go to that and it places a result. This is a common bus structure. Is it clear, ma?
Yes, ma'am.
Should I repeat or is it clear? So let me see here. So we have a memory. So when we'll be going for reading operation, so we'll be going to that particular address, we'll be taking instruction, and if data is data, and we'll be placing in particular registers, and it can perform load, increment and clear. Only for instruction register we'll be having a load. Why? Because instruction will be having a 3 partitions in that, so we cannot go for incrementing that. And even a output register also we have only a load which is used for storing the output result, and from this output register it goes to a output to a monitor. This is a common bus system. So now let me go for computer instructions. Okay, so see here, ma'am. So I already said that. So whenever we are instruction, it will be taking an instruction, it fetches, it decodes, it executes. Now if from which instructions may be present in a memory, okay, that everyone knows. Instructions will be placed inside a memory. From memory you will be taking one by one instruction for execution. Now the other location where an instructions can be present is registers. Okay, so see here, we'll be having 3 instructions. One is memory reference instructions. Instructions may be present inside a memory, or register reference instructions, means the instructions are available in the registers. So when a processor wants to execute an instruction, if that instruction is available in the registers, then there is no need of going for a memory for fetching an instruction. It is available in the register itself, is register reference instructions. Or it may be either from external peripheral devices. Okay, so we'll be calling that as input output instructions. Okay, so input output instructions. Okay, so for that we must know the instruction format, what will be the look for memory reference instruction, for register reference instructions, and for input output instructions. So coming for memory reference instructions, you will be having an address. Okay, you will be having an address 0 to 11. This we considered first 4096 into 16. This is the memory that we have considered. This is a memory. Okay, so 4096 into 16, this is a memory. Okay, so for that it is mentioned, this part is what, this part is what, ma'am? This 4096 into 16. So what is this? What is this? This is what?
Address data.
Yes, 4096 is an address and the 16 is a data. Okay, and 16 is a data. So here 4096 means 2 power 12. So you will be representing with 0 to 11 as address, and 12 to 14 as opcode, and 15 as a whether you are going for a direct means the address which is specified here, is it a direct or indirect. So that will be decided by the 15th bit. So that is memory reference instructions that we have discussed. Now register reference instruction. So in a register reference instructions, registers will be only few registers. So where we will not be having any address. So memory is what? Memory is a huge, where in order to go to a particular instruction, you need to specify an address. Okay, where you need to specify an address, where registers are only few registers. Okay, so where we will not be giving any address for registers. And so in place of an address, what operation that you want to perform in that register which is present in that. So whether you want to do what operations, whether you want to do circular, left shift, right shift, all those will be present in this register operation. What operation you will be doing. Okay, so next input output also, what type of input output operations that you want to perform. If it is input output instructions, only address will be available in memory reference instructions. Why? Because the memory size is more. Wherever the instruction that is present, we have to mention with an address. So 0 to 11, if it is memory reference instruction, we'll be having an address. If it is register reference instruction, 0 to 11 will be having a register operations. If it is input output instruction 0 to 11, it specifies what type of input output operations it is performing. Okay, so let me show with an example. For before that, see an opcode. I'll try to concentrate. This opcode, how a system knows that. If I already said that the internally system will be like this. Okay, so you'll be having 0 to 15, and it will be having like this. Okay, so like 1010, how many bits, ma? Like until 11 bits, 11 binary bits will be there. This is an address if it is memory reference instruction, and opcode, let us consider 001. Opcode is 3 bits, 001, and mode is 0. Okay, so how can, by seeing this bits in a binary, how can a system identifies that this is an instruction which is from memory, or this is an instruction which we can get from register, or we can get from input output instruction. That is depending upon an opcode. So see here, try to understand what are the different opcode operations, basic computer instructions. So this is your memory reference. This part is a memory reference instructions. This is your memory, and this part is what? This part is register, and this part is input output. So this part is a register, and this part is a input output instruction. So here, so we have add, and add, LDA is load, STA is store, BUN is branch, and conditionally BSA is branch and save return address, ISZ is increment and skip F0. Okay, these are the some of the operations that we will be performing in memory reference instructions: adding, loading, storing, branch and conditionally, branch and save return address, increment and skip F0. These are some of the operations will be performed in a memory reference instruction. So there will be totally, how many are there? Count and tell me. How many are there? How many symbols are there here? How many?
7, ma'am.
7. Yes, 7 means, as we are starting from 0, it starts from 0 to 6. 0 to 6 means in order to mention this, you will be having 0, 0, 0. And that indicates in an opcode, if we have 0, 0, 0, that indicates it is and, it is performing and between the word which is present in a memory. So and memory word to accumulator. So here what we are doing, whatever the contents we are having in an accumulator and whatever we have in our data register, both will be performing and operation. So that indicates by a mnemonic, whatever we have in an opcode, if it is mentioned as 0, 0, 0, that indicates it is and. So if it is mentioned, let us consider it is showing as 1. So if it is like 0, 0, 1, that indicates it is performing add. If it is 0, 1, 0, 0, 1, 0, that indicates it is load. If it is 0, 1, 1, that indicates it is, if it is 0, 1, 1, that indicates it is store the contents of accumulator into a memory. I already given a clear difference between what is a load and what is a store. And branch unconditional is if there is unconditional jumps, it branches to that particular location. So these are all some of the operations in opcode operations that are in memory reference instructions. So totally we have a 7. So 0 to 6 is sufficient. So 3 means you will be representing. 3 means what? How many combinations you will be getting? 2 power 3 means how many combinations you will be getting? 8. 8, right? But in that 8, we are using only 7. 0 to 6 is 7. Okay, we are using only 7. Why? Because we have only 7. So that's the reason it is mentioned here 0 to 6. Okay, 0 to 6. That is, we have 7 totally. Memory reference instructions, we have 7 totally. So that's the reason we have mentioned as 0, 0, 0 to 1, 1, 0. Okay, now see here. So let us consider register reference instruction. So register reference instruction means clearing the accumulator, clearing the extra bit called a flip-flop, complementing the accumulator, complementing a circular right shift, circular left shift, incrementing. These all are the operations in a operations in what? Register operations. These are all the operations that we will be performing. Okay, so here these are all the operations that we'll be performing in a register reference instructions: clearing, complementing, circular left accumulator, circular right accumulator and E, circular left accumulator and E, increment the accumulator, skip next instruction if accumulator is positive, skip next instruction if accumulator is negative, like that. These are some of the operations that will be performing in register reference instructions. So for that, see here, it is 7. 7 is represented with tell me, this is hexadecimal. See ma, this is hexadecimal representation. So if it is hexadecimal representation, we have a total 16 bits, right? Instruction, do we have a 16 ma? Instruction format 16 bits, huh? Yes. So for a 16 bits, if you want to represent in a hexadecimal representation means it occupies 4 bits. So you will be getting total 4. Okay. So this first 4 indicates what ma? In register reference instruction, 7 is represented as, it is hexadecimal representation, 7 is represented as 0,111. In this 0,111, again we have done 2 partitions in this. What are those 2 partitions? Opcode. This 3 comes under an opcode. First one comes under a
Mode.
Okay, so this is the we'll be considering as I. So as this is register reference instruction, we cannot say that as a mode. Only for memory reference instruction, we'll be calling a more significant bit as a mode. So let me explain. And next, the remaining is this part. Try to concentrate ma. So we have a 16. So 16 bits we are representing in hexa. So you will be having 4. So each will be representing with 4 bits. Okay, 0 is represented as 000 and 1 is represented as 0001, like that. So we stopped until 6. Why? Because we have only 6 operations that can be performed in memory reference instruction, and this is what? A direct. So we have an I. If it is equals to 0, I said that it is direct. If it is equals to 1, I said that it is indirect. So here 8 is represented in hexa. Tell me the 8 ma. 8 is what? 1
1000.
1000. So this is a 4 bits. So in this again we are giving partition. This will be considering as I. This will be considering as opcode. Means what? So by seeing this most significant bit 1, what a system can understand? It is a indirect address. And by seeing this 3 zeros, what a system can understand? It is a memory reference instruction. So memory reference instruction, if in an opcode, if we have 000 to 6110, if in an opcode, if we encounter this, then a system can identify that these are a memory reference instructions. These are memory reference instructions, and a mode bit will decide whether it is a direct memory reference instruction or indirect memory reference instruction. The same case, let me go for 7. So if it is a 7 in hexadecimal, will be represented as 1. Is it what 7 as what ma? 4 bits in hexadecimal. How to represent?
0111.
0111. So in this we know that 3 bits will be for opcode. So by seeing this, system can identify that is it a memory? 111 indicates is it a memory reference instructions? No. Why? Because it will be having only 0002 110. 111 indicates that it is a register reference instructions. 111 in an opcode, system can identify that it is a register reference instruction. So to execute that, we need to go for any one of the register for fetching that instruction. So that is register. Now 0 indicates it is. By seeing this 111, try to understand mas, by seeing this 111 in opcode, system will have an idea that it is either a register reference instruction or it is either an input output instruction. So based on I mode, it will decide whether it is register or whether it is input output. If it is 0, then it is input output. Now let me represent F in binary. Tell me ma, F in binary is what? F is what? Which number? F is which number, ma?
15.
15 is represented in binary as
1111.
1111. Give a partition. So this is your opcode, right? So even in register reference instruction also, and even in input output instructions also, for opcode we have 111. But how can a system identify that this is a register reference or this is an input output? How? Based on a more significant bit. So if we have a 0 in this, then it indicates which instruction, ma?
Register.
If it is 1, then it indicates
Input output.
yes, good. So it is clearly, so if an opcode, in an opcode place, if we have 0 0, this is the place. Okay, so in an opcode, if we have 0 to 6, then a system will know that the instruction is memory reference instruction, and whether it is direct or indirect will be decided based on a 15th bit, based on a 15th bit. So in the same way, so instead of this 6, if it is mentioned as 7, means 111, a system only knows that it is not a memory reference instruction, but it may be either a register reference or it may be either an input output. So but system has to know whether it is register reference or input output. That is based on the 0. So if I equals to 0, then it is register reference instruction. So if I equals to 1, then it is input output instructions, and it is input output instructions. So these are the input output instructions. So this is the first bit is used for representing 4, and remaining 800 is used for representing register operation. The first bit is used for representing opcode and the decision of whether it is IO or whether it is register. Next is used for representing input output instructions operations, input output operations.